P1 and P2. Who will maintain this pressure difference? External force. So this will become inertial force. No? So this is having area A1, A2. Or we need not. Yeah, it will be like this. So here P1 A1 minus P2 A2. So this will lead to what? Inertial force. External agent should do no that one. It should maintain a pressure difference, liquid will flow. But as the liquid is flowing, so the different layers of liquid, they will experience what? A viscous drag. So here what do we get? Viscous drag or viscous forces. So what is this? Definitely what happens, there is some relationship between this inertial forces and the viscous drag. What are inertial forces? A force which will make the fluid to move from one point to another point. So that is what the pressure difference. Am I right? Shall I call inertial only? This is justified, no? Pressure difference. So how do we can measure pressure difference? I think quite easy, no? Quite naturally, we know fluid dynamics, everything. Okay, now, so definitely there is some relation between this inertial and viscous forces here. So for that, what will happen? We'll define a Reynolds number. So what is the Reynolds number? The basic definition will go like this. Reynolds number, ratio of inertial forces to viscous forces. So this Reynolds number, I'll write RE symbol. So what is the initial forces? Mass into acceleration. What is the viscous force? So dynamic viscosity or quotient of viscosity it is called as. Velocity, then area divided by distance. That formula only F equal to eta A dV by dr, I'm writing it. Okay, let's check the dimensionally. Now, what is the mass? Mass, we can write it as rho L cube. What about the acceleration? Acceleration shall we write v square equal to 2s. So acceleration will be. I'm trying to get some quantities related here. This is the u eta. Quotient of viscosity is eta. Then velocity what you can write v. Area L square. Distance again is L. So when I solve all this, so what do I end up? Rho, one V get cancels. V is speed, V means velocity here, this one. Any other quantities will come, rho V, eta. Shall I say one L will end up here. So what is V? V is the speed of liquid. Let's define all these terms because this is very important. RE is what? Reynolds number. Rho is what? Density of liquid. Eta is.
Sir, L will be in the numerator, sir.
L will be the numerator. Rho V L by eta. Yeah, fine. Okay, eta is called as coefficient of viscosity. Then what we have, V is speed of the liquid. This L further what we write this L as the diameter. So this is a capital D only, let me use. Capital D only will use it. So D is what? Inner diameter of pipe. In which viscous liquid is flowing. This is very important. So now, based on this viscosity, what will happen? Based on this called a Reynolds number. So I can now say that if Reynolds number is less than 2000, it is called like a streamline or a laminar flow. If the Reynolds number happens to be more than 4000, then it is said to be turbulent flow. And if it is between 4000 to 2000, so then it is said to be unstable. Means sometimes it will be streamlined, sometimes it will be turbulent flow, unstable flow. Why do we need this? See, I have to check, no, like is it a streamline or turbulent flow? So that is what we put it. So usually what happens, we want laminar flow here. So this I will rewrite. So I will rewrite Reynolds number eta equal to rho d. I'll substitute here. I know what is the type of liquid I'm using. I'll always go for streamlined flow. I'll put around 1500. Then quotient of viscosity, I know inner diameter of pipe, I know the density of liquid. With this, if I solve, no, I'll get a velocity called as critical velocity. So what is VC? VC, we'll call it as I will calculate like this. Fine. This one usually Reynolds number. Let me pick up 1500. I know what is the type of liquid I'm using. Either I'm using honey or ghee, coconut oil, or some any denser liquid or water. I know quotient of, I know density of liquid. I know the diameter of pipe through which that liquid is passing it. Then I'll get the critical velocity. Then what I say, streamline or turbulent, I'll put a condition. If V less than VC, streamline. If V greater than VC, it will be turbulent. Streamline, or you can call laminar flow. Both are same. So the critical velocity depends on what? You are going to choose Reynolds number. And this depends on the liquid. Am I right? And this depends on the pipe. Even the pipe matters a lot. That's why it's very important here. So what is the diameter of pipe? The diameter of pipe will help us to check that one. Able to get this. So now what happened? It's very easy to measure the velocity of a flowing liquid. I'll check it less than or greater than. If it is less than, laminar flow, greater than critical velocity. Greater than critical velocity, turbulent flow, less than laminar flow. Just I think it's some data which you have to remember, nothing big. Okay, now regarding the pipe, sir, like can you show in the pipe what actually happens, because you have brought diameter of pipe. Shall I continue? It's just only dimension analysis. That Reynolds number is something very, very important, because when the liquid is flowing, it will encounter two forces, one inertial force and the viscous force. Clear this one. So the ratio of that what happened will determine. So definitely you can see this here. Reynolds number, for it to be higher number, if the inertial force dominate over viscous force, it become turbulent. Clear this? If the inertial forces become dominant on viscous force, but sir, even 1500 also dominant, if very dominant, Reynolds number, if it is greater than 4000, means definitely the inertial force what mean is 4000 times more than viscous drag is acting, then it become turbulent. I think this is what happens, no? When rain comes, what happens, the adjacent water molecules will be pushing each other. Then if it 4000 times, if the inertial force is acting on the layers, if it is 4000 times more than viscous drag, then it will become turbulent. This is the idea. Okay, let me go to the, no, I'll show this. Okay, let's keep this data. Okay, if I take the pipe, Okay, liquid is flowing through a pipe. This is only theoretical. Once you get this one, no, rest all will be very easier. It's just only formula based. Now, if you see the laminar flow of the liquid will be like this. Turbulent flow of the liquid will be. So means a layer of a liquid. What is this? So I think I'll bring the axis. This is the pipe, cylindrical pipe. I think I'll give a better picture. Okay, liquid is flowing, So if the layer of the liquid which is there at the axis, it is having more speed than the layer. So what is this? This is a velocity profile. So inside a pipe, when a liquid is flowing, the profile will be like this. I should bring arrows. This is called like a velocity profile. Able to understand, no? So the layer of liquid which is there at the axis will have maximum velocity, and as you move, what happens? The layer of the velocity of the layers will keep on decrease, and the layer which is at the edge, what happens? It's a plane diagram. Try to understand. It's a plane diagram. The layer which is at the edge, what happen? Almost it will be at rest. This was the velocity profile. Now what will happen? If the difference between these two is more, if the velocity difference between the layer at the edge and the axis is more, it will be streamline. If it is less, it should be turbulent. So this is what streamline flow. Fine. So there's a basic condition what we can put it here. So if the liquid and this velocity profile, do remember. So there's a pipe. What it is, well, what this diagram shows, velocity of various layers of viscous fluid flowing in pipe. Fine. So this is about the theory. So we will say goodbye to all this. This is just only theoretical information. We'll get into the application part because we have to do numericals. The two what happens, something mechanics related. Okay, let me start with this one. I do have, so I'll take a surface. I'll take a block. Okay, before that, no. This is the layer. I'll give that one.